This is sort of a first philosophical interlude in the school. We haven't really gotten into terribly formal, game theoretic concepts or notions, which I think essentially will emerge as we explore different settings. You will see that some ideas sort of permeate all settings. In particular, in most scenarios, you are going to have agents who are rational. You could even think of them as being selfish, who play according to their self-interests. What does it even mean to play? So what is the notion of a game? Typically, you are, in most intuitive games, essentially you have a bunch of rules and you have a goal. There is a clear concept of winning, and you play by the rules. Maybe sometimes you try to even break some rules, and you try to do your best to win. Formally, okay, we are not going to do anything formally in this lecture, but typically you have players, you have possible moves that the players can play, and what you want the players to come up with is a strategy to maximize their so-called payoff or utility or output. That's the gain that they get from the game. I mean, in a typical game, when you think of a game, there's usually a player that wins or loses. These are combinatorial games, but the kind of games that we look at in game theory are in a slightly different sort of a setup, where, as I said, you play a move and you have information. The input is essentially information about what happens if you play a particular move and the other agents play certain moves. Then what is the payoffs that all the players get? That is essentially that's essentially the information that you're dealing with, and the goal is to figure out a strategy to, in some sense, play optimally. So we're going to try and just experience some of these ideas by actually getting some practice playing a game. As I said, none of this is going to make any of these ideas formal. That's not the intention with this, with this lecture. The intention is to just have some fun and, try and see if we can get philosophical for a bit. And hopefully in the rest of the lectures, some of these ideas will sort of keep surfacing again and again. And by the end of the school, you will have some, some concept of what some of the universal ideas in game theory are. Okay. So this is a really nice demonstration made by somebody called Nikki Case. The website is ncase.me. I'll put up a link on the school's website so you can go and explore it on your own time. But for now, what we are going to do is try and play this simulation together. And this is based on a book, so I think at the very end there are a bunch of references, which I really encourage you to look up if you're interested. So in particular, I think there is a book called The Evolution of Cooperation, and a more recent version of it is called The Complexity of Cooperation, and these are two very interesting books on which this simulation is largely based. And then there are some other visualizations that are also interesting. I think I have, okay, I need to go back here. And the setting is some story about, I think this was the First World War, when, soldiers across borders, I mean, basically crossed borders, and during the Christmas of 1914, basically hung out and, laughed and cried together. This is apparently a famous story and something that happened in multiple places during, during that winter. And I think both the book and this simulation here start off with the question of why, what can possibly explain this sort of a phenomenon where people who have been fighting for several days on and have strict orders from the top to not indulge in any kind of, mischief, end up actually making peace. I don't know if this is, maybe you guys are too young for this, but there was a Coca-Cola ad along these lines, which you may or may not have seen, which was very touching. It was about, soldiers on the Indo-Pak border sort of getting together and, being friends for a few minutes. And on the other hand, this is being contrasted with the fact that in times of peace, we are moving into a society where there is apparently less and less trust, and people are more and more conservative and less willing to, basically be friends and trust each other. So as I said, the setting is a little bit philosophical, but we will try and we will try and understand it through a concrete game and see if any ideas sort of emerge. So this is the setting, and those of you who have heard of things like the prisoner's dilemma may find this a very familiar setup. But this is also similar to a British game show which was trying to recall the exact name of the show. I think it was called The Golden Ball, but I'm not completely sure. So essentially it was a game show where there were two players who had who had a common jackpot to win, and you could either split or steal the jackpot. Okay, and the two players would have to independently make their choices, and if both players agreed, happened to decide to split the jackpot, then the jackpot would indeed be split between the two players. If both of them decided to steal the jackpot, then nobody got anything. But if one of the players decided to split and the other decided to steal, then the player that decided to steal would dominate the game and get the entire jackpot. Okay, and in the interest of television being television, in the interest of drama, I think they would have a section where they would let the players actually talk to each other before they actually played the game. And there are some clips up on YouTube from some of the most dramatic episodes of this show, and it's quite interesting the extent to which people try to convince the other party to also basically split. And then there's a lot of the reason there is TV drama is because there's a lot of betrayal in spite of all the acting up front and so on. So there are some, there's a very interesting episode in which one of the players told the other player that, so typically it plays out as both the players trying to convince each other that they're honest and they're going to split. So what happened here was that one of the players walked in and said, no matter what you do, I am going to steal. So you figure out what you want to do, but I am going to steal. But if you decide to split, then I will meet you in the alleyway outside the showroom, and I will actually split the jackpot with you later. Okay, this is what one of the players said, and the other chap, poor guy, not having. This is very unusual. So the other player tried to convince this guy to actually split. He said, "Don't be silly. I'm going to split. Why don't you split with me?" And he said, "No, I'm being very upfront with you. I'm going to steal. So you do whatever, but I will steal. But if you decide to split, then I will split the jackpot with you later, outside the show." Okay. So the other person, the way the episode played out, the other person felt like they had no choice. If they decided to steal, they were anyway not going to get anything. And if they decided to, they knew that they were not going to get anything in either scenario. So they thought they might as well look good to their friends and family by saying that at least they did the right thing and they decided to split. And what ended up happening was that the gentleman who was saying that he is anyway going to steal played to split, and the other person also split. So it was a happy ending. It was a very rare episode in which both of them actually split. But for the most part, it's a game of betrayal. So it's a game of who acts better during that conversation. And it's either that both of them steal or that one of them split and the other steals. Both of them splitting was a rare occurrence on the game, and this was one of them where this guy pretended that he's going to steal and then did a sort of a reverse betrayal. So it's interesting, and I think the show was quite popular and it ran for 2 or 3 years, and I think there's a lot of interesting psychology, a lot of things that you can get out of watching some of those episodes. So this is a very similar scenario. You have a machine here and there are 2 players, and the rules are the following. So if you put a coin into this machine, then the other player gets 2 coins. Okay, that's how the machine operates, and in fact not even 2, actually 3. So I'm even remembering it wrong. So the other player gets 3 coins. You put in a coin, the other player gets 3 coins. If the other player puts in a coin, then you get 3 coins. Okay. So you have 2 possible moves. You could either decide to cheat or you could decide to cooperate. So what it means to cooperate is that you put a coin into the machine, and what it means to cheat is that you don't do anything. You don't put a coin into the machine. Okay, those are your two moves. And here is our first attempt at analyzing this game, which is to say, so typically when you play this game, you don't know what the other player is going to do. Okay, so the machine is standing between you, you have no auxiliary information about the other player, you don't know anything about their character or history, and it's a completely blind situation. But just for the sake of analysis, I'm going to propose that we think about what happens if the other player decides to cheat. What is your best move? So I'm going to actually put this to a poll, and I'm going to ask all of you to pull out your phones and actually actually vote for what you want to do, and I'll decide based on that. So go to menti.com and enter this code. Okay, sorry, I still have to reset. Sorry? If both of them cooperate, both of them get 3 coins with a net of 2 coins because you put 1 coin in, so your net payoff is 2. But yeah, the machine will give you 3 coins and you've lost 1. That's correct. So the rules of the game are clear, right? Meaning you put in a coin, the other guy gets 3 coins, and now you know that the other guy has decided to hold back. Sorry. So 81625. So I don't know if it is wise to reveal these results as they are happening. Please vote according to your according to what you think is the right thing to do. Don't be influenced by all the cheaters in the room. Now this is also to say that I mean, some of you are thinking of cooperating, and I'm wondering why. In the following sense, I mean, is the goal of the game clear? So I didn't really. It was sort of deliberate, but I didn't really get into what the goal is. What do you want to maximize? What is the desired outcome? What do you think? What are you playing for? Coins. You're playing for coins. That is actually correct. We are playing for coins. You could be playing for other things like I'm not sure, demonstrating nicety or building up trust over a period of time, for instance, and so on. These could be other considerations, given that this is an informal sort of a setting. But for now, we're keeping it simple and playing for coins. It's a one-off game, so there isn't really opportunity to build up trust by playing nice. So you might as well be greedy. So I think there are at least 25 people in the room, so I'm going to wait for everyone to pitch in. Okay. So given the gap, I don't think we have enough people to turn this in the favor of cooperation. So I'm going to go and vote for cheat. And that turns out to be the right answer in a certain sense. When you are playing to maximize the number of coins, it makes sense to cheat if the other person is cheating, because you are not going to get anything anyway, and why bother losing a precious coin and giving the other guy 3 coins, right? So essentially, when you know that they are cheating, you have 2 options. You could either cheat or cooperate, and if you cheat, then the situation is 0-0, and if you cooperate, the situation is -1-3, and from your perspective, 0 is better than -1, right? So it makes sense to cheat. What if the other person cooperates? This is the other possibility. What if the other person cooperates? What should be your move? So think about it and respond. The other person is being nice. Should you reciprocate or should you take advantage? Okay. This is a smart crowd. So even if the other player is cooperating, it appears that most of you still want to cheat. Which is a little sad. Okay. Anyone else who has to vote yet? Okay, it's kind of close, but it's still a majority for cheating. So I'm going to go ahead with cheat, which is kind of mean, but also smart, in the sense that if the other player is cooperating, then if you cooperate as well, then it is a 2-2, right, which is what you pointed out, right? If both of you cooperate, then the net is 2-2. But if you cheat, then it is 3 minus 1, right? I mean, you get 3 and 3 is better than 2. So even when the other person is cooperating, it is better for you to cheat, okay? Which is our paradox essentially, which is that you have this machine here which can presumably make you both rich, okay, but you have decided to cheat no matter what the other player does, and you are not the only smart person in the system. So the other player is going through the exact same reasoning, and so they would also cheat no matter what you do, which means that both of you are left in this endless cycle of mutually cheating each other, and neither of you get anything out of the machine, which could which just seems like such a waste, right? You could both be cooperating in every round, and you could be getting 2 gold coins net in every round, but somehow your rational side prevents you from doing that, okay, which is pretty crazy if you ask me. So that's our dilemma, as is pointed out here. So how do we analyze this further? So this is the situation. Is this clear? That with this sort of, this is what you would call a payoff matrix. These numbers which tell you, you can read off what's going on here. So your move, their move, and for each combination you see what you get, what they get. That's essentially a payoff matrix, right? So everything that we have said so far is fairly logical for a standalone game. Let's try to dig a little bit deeper and understand what happens when you play this game multiple times, okay? So here is what is going to happen. We are going to face off with multiple players multiple times, okay? There's going to be 5 different players, and with each of them we are going to play between 3 and 7 rounds. The total number of rounds is uncertain. And we are going to try and maximize the number of coins. That's still our goal. But since it's a repeated game now, you both have opportunities to understand each other based on your past moves, and you want to optimize based on that, okay? So the question is, can you trust the other player to cooperate with you, and more importantly, can the other player trust you to cooperate with them, okay? So let's get started with the first player. So this is, you're going in blind, you know nothing about the first player. What is your opening move going to be? So I'll only do this for the first move. After that, I'll just randomly volunteer people to tell me what to do. So okay, this is fairly close. This is a player about whom you know nothing, and the other player also knows nothing about you. So your first move is going to really set the tone for how the remaining rounds are going to go. So since this is fairly close, is there anyone left in the room who can swing the vote, because right now we are cheating with a margin of 2 votes. So, okay, I'm going to wait for another 10 seconds, and if this doesn't change, then I will open by cheating. Okay, so that's what we are stuck with. So we will open cheating. I'm just tempted to bring back the sound effects because they're kind of cute. So we start by cheating. Okay. We made the other dude sad. Your next move. So you cheated, the other person cooperated. This was the best possible scenario for you because you got 3 coins. That's the most you can get in a single round. So let's just start from you first row. What do you want to do next? Okay, so now that the other person has seen you cheating, they are probably going to move into revenge mode, in which case you would only be at a loss by cooperating. That is the logic. So once you started off by cheating, maybe, I don't know, sounds like a very filmy dialogue, but you have to continue cheating. Okay, I mean, yeah, so exactly as predicted, the other player decided to roll up his sleeves. He opened on a trusting note, you cheated him, and now he cheated you back. Okay. What's your next move? Okay. Make up for your sins, see if you can win back some trust. You. Okay. So that was not very surprising. I mean, given that you really given him no reason to cooperate so far. But now the other guy has seen you cheat twice and cooperate once. I mean, we can't blame him if he cheats, but I don't know what he'll do. So what do you want to do? Achha. Cooperate, take advantage of being nice, give it a shot. Okay. Not bad. So you managed to actually gain back trust reasonably fast. So both of you have been nice this round. What do you want to do next? Okay. Back to old ways. Okay. All right. भगा दिया उसको मतलब he's okay. So the player is frustrated, left. So now we have a new player. So the new player doesn't know anything about your history. It's a fresh game. How do you want to play this? How do you want to start? The opening move is always a fresh slate with any player. They are not aware of your history. So it's an opportunity to either start off on a positive note or make your intentions clear from the start. I don't know, yeah. So okay, this is a clear majority for cooperate, so it's not going to change. So you start out cooperating. No dice, you started, I mean, your intentions were good, but you got cheated in the first round. This is like what happened with you, I mean, what you were doing in the with the previous player, right? Okay, so you get a taste of your own medicine. How do you want to continue? So it's your turn. Batao. Cheat. So revenge mode, you got cheated, you want to cheat back. Okay. So both of you have smartened up. How do you want to continue? Cheat. Nobody is relenting here. What do you want to do? Cheat. Okay. Okay. So this is like the prisoner's dilemma playing out pretty much. You just kept cheating each other. now you have a new player. You can't see on the other side of the machine, okay? So don't get distracted by the looks. Let's just let's just start out. How do you want to start? The bitterness of the current round is playing into the next one, I'm afraid. This is a fresh player. Okay, so I'm afraid it's going to be cheat. So let's start out cheating. Oh. Alright, so the new player is all sad thanks to the cheat move. She was cooperating. You cheated her. How do you want to continue? Yeah, that's a good point. I'm going by the hat, but yeah. Um, yeah, so you cheated him or her, and yeah, what is your next move going to be? So cheat again. Okay. It's kind of pushing your luck, but okay, yeah, all right. Definitely a she, because if you're going to be that trusting, so yeah, okay. So she's cooperated twice by now. You've cheated twice. Let's go to the third row from the last. How do you want to continue? Cooperate. Okay. It's like faith in humanity is slowly being restored. You cooperate, and she continued to cooperate in spite of the fact that you cheated twice. How do you want to continue? Cheat. It's interesting. Why do you want to cheat at this point? I mean, and she will probably she will try to, and okay. So you're imagining that she will cooperate. She's cooperated thrice in a row in spite of your cheating. So it's reasonable to predict that she will cooperate. The question is, how do you react to that? I mean, you know that she's going to cooperate, and based on the discussion we had at the end of the first couple of slides, we said that if you know that the other player is going to cooperate, your best move is still to cheat. So that's what you're doing here. But remember that this is multiple rounds, so if you keep cheating, it's possible that they also get annoyed and they change their behavior in the future. So that's the additional dimension here, but locally in this round it does seem optimal to cheat knowing that she is going to cooperate. So let's see what happens. So yes, as predicted, it went your way and she also went away. So we now have a new player, and I'm going to ask you, how do you want to start? Now that you have driven away the nice player, let's see how do you want to open the new innings? It really looks like the nicety of the previous round has rubbed off on everyone. It's quite interesting, even though the rounds are completely independent. But okay, so we want to. So this is a huge gap, so even if there are more votes, the outcome will not change. So let me start by cooperating, right? So both of you are being nice. Okay, what do you want to do next? Cheat. Okay, smart one. So let's. Okay, that went your way. What do you want to do? Cooperate. Okay. All right, let's cooperate. Okay, that didn't quite go your way, but okay. So what do you want to do next? Cheat. You're really confusing the other player at this point. Okay, he's probably going to think of you as a completely random player, but okay, all right. So this um, was okay. So this didn't really go. I mean, yeah, it would have been better if the other person had cooperated, but that did not happen. But all right. So you cheated, got cheated. What do you want to do? Cooperate. Okay, let's try to cooperate. Okay, you cooperated and you got cheated. That last round was funky because we were just alternating pretty much, and the other player probably had a hard time reading you. I mean, I don't know. I don't know how to analyze that one. But this is your last opponent, your last fresh opponent. How do you want to open? Okay, it's a very thin margin, but it looks like we want to cheat, so start by cheating. Okay. I don't know what price you'll have to pay for this later, but okay, right now it's gone your way. So, okay, let's move to the previous row. What do you want to do? You've opened by cheating, so cooperate. Okay. Again, presumably the other player is likely to cheat, but you never know. So let's cooperate and see. So, okay. How do you want to continue? So you have cheated and cooperated. What do you want to do now? You can always toss a coin to decide if you're not sure. That's actually often a pretty good strategy, to be completely random. Okay, cheat. Cheat because you're too nervous to cooperate now. You've already been cheated. It's kind of surprising. I mean, yeah, this went your way. I wouldn't, yeah, okay. So, all right. So let's see. What do you want to do next? Cheat. Kind of pushing your luck and also getting lucky, which is interesting. Yeah, okay. What do you want to do? This guy's going to catch on at some point. I don't know when. Yeah, about now. So, yeah, okay. So, cooperate. Okay. You got cheated, I'm afraid. Would cheat. Like. There was two very confused players at the end. So wasn't okay. So it turns out that all the players that you played with were actually playing according to fixed strategies, and these are the strategies here. The highest possible score was 49, and you scored 30. So I would say that's not bad, especially not knowing who the players are. But you probably caught on with the second and third players who were always cheating and always cooperating. That was their strategy. No matter what you did, the second player would always cheat, and no matter what you did, the third player was always cooperating. The first player was basically copying your last move. So if you remember, you cheated twice, then you cooperated, and then the other player cooperated in the next round. So that's the copycat player. The fourth player, the grudger, is this friend that we all have who starts out cooperating, but then they never forgive you if you make a mistake. So that's the grudger. So if you cheat them once, they will behave like always cheat for the rest of their lives. Okay, so if you cheat them once, there's no looking back. With the detective, which was the last player, there's a slightly funky strategy. They analyze you for the first 4 moves by playing cooperate, cheat, cooperate, cooperate, and they observe you during this time. And if they ever observe you cheating back, right, so they know that you are capable of cheating, then they switch to copycat strategy. But if they see you always cooperating, then remember when you also saw that this player was always cooperating, you felt like always cheating because you saw that there was an opportunity to take advantage and you decided to take advantage. So that's what the detective is doing. So if you never cheat back, I'll act like always cheat because that seems optimal, right? So now the next question we want to ask is, what happens if these players play against each other? So how are we going to play this out? So we have these 5 players and we are actually going to do a pairwise tournament. This is similar to what we were doing in the previous lecture, for instance, except that now we just have these 5 players and we are going to have each of them face off over a period of 10 rounds of this game. And the outcomes are completely predictable because the strategies are fixed and deterministic, right? So you know exactly what is going to happen. So for example, when always cheat plays with always cooperate, what happens? For 10 rounds, what is their balance sheet? Minus 10 and 30, right? Because always cooperate cooperates in every round and she never gets anything back because she's always being cheated. So her balance is minus 10 and the player that is always cheating is always getting 3 coins without spending anything. So that's a plus 30. So you can run these games across all the pairwise contests that are there here, add up the coins, and I want you to speculate about who will win. So you don't have enough time to probably work everything out, but just make an educated guess based on your intuition for these strategies. So you remember what the strategies are, right? Always cheat and always cooperate is clear. Copycat copies your previous move. Grudger starts out cooperating but once cheated always cheats. Detective does something funny for the first 4 rounds and then switches to either always cheating or switches to copycat, depending on, like, if you cheated him then he switches to copycat, and if you never cheated him then he switches to always cheat. So that's the 5 players. So who do you think will win this tournament? Okay, maybe I shouldn't be displaying this. So nobody thinks that always cooperate has any chance of winning, uh, which is fairly sensible considering she's too nice perhaps, but it's also understandable that always cheat and detective are at loggerheads because detective strategy is very close to always cheat, but he seems to be doing something marginally smarter by imitating copycat in some situations. So it just sounds smarter. So I want the 25th voter to break the tie so I can make a guess. So I do know that somebody has not voted because we have had 25 or 26 in the past. So great, all cooperate. That doesn't help. So if anyone has a vote left, yeah, I don't want to force you to make it between always cheat and detective, but I need a tiebreaker or I'm going to do it randomly. So wait for 10 seconds here. If somebody wants to decide this, you can. Okay. Yeah, so these choices are fairly similar. So I'll go with detective because of the fact that it sounds like always cheat plus some smartness on top of it. So maybe that's maybe that makes it the most interesting contender. So I'll go with detective. Okay. So we're going to play these matches out. I don't know how much. Okay. So in the interest of time, I will actually just run you through the numbers. You can, as I said, play this in your own time and verify that they are correct. So the simulation also has a bit of storytelling, which I will skip, but please feel free to go over it in your own time. So this is copycat versus always cheat, so copycat gets cheated in the first round, but then catches on by copying always cheats previous moves all the time. They end up in this cheat cycle. So that's the balance there. Copycat versus always cooperate, they play nice with each other, so it's 2-2 in every round. Copycat versus grudger, so notice that if you never cheat, grudger is like always cooperate, right? If you never cheat, then grudger always cooperate, so it's very similar. Copycat versus detective, there is some up and down that happens because of the funkiness that detective has in the first 4 rounds, but eventually it plays out nicely. Always cheat versus always cooperate is the most merciless match of all of them. So this is the plus 30, minus 10 that we talked about. It's really quite ruthless. Always cheat versus grudger, again grudger starts cheating once cheated, so it's like always cheat versus always cheat. So always cheat versus detective, again some funniness in the beginning, you can check that the scores work out as advertised. Always cooperate versus grudger, again there is cooperation throughout because grudger never needs to cheat. Always cooperate versus detective, this is the case where we said detective detects that you are cooperating and then he slips into always cheating. So this is also a bit of a massacre, just a little bit better than playing with always cheat because of the first, there is one round where detective cooperates, but other than that it's pretty sad for always cooperate. Grudger versus detective, again they're playing off of each other, 7 and 3, something that can be checked. And the winner is copycat. Look at the numbers that were being tallied up so far, the winner is copycat. Can I ask who it was who voted for copycat? Okay. Alright. Okay. So, not surprised. Yeah, so it is counterintuitive, so I wouldn't have guessed either, but it does seem like always cheat has the, always cheat or detective are really playing in the most selfish way possible, and therefore the greediness should work out in their favor, but it turns out that it doesn't. They're not very far behind, but there's still a substantial gap, so it's 45 versus 57. So this is, as I said, there is some philosophy about copycat strategy, and I think if you look at the book on which the simulation is based, they actually, I think the author of the book actually advertised this problem and invited submissions for programs that could play a random opponent. And there was one submission which was the copycat strategy, and it ended up beating pretty much every other strategy that was submitted. So these are a few, but copycat is pretty robust against several strategies, perhaps to the exclusion of random strategies where things are a bit harder to analyze. But it seems like something powerful is going on here, but let's dig even a little deeper to ask ourselves if this is just some fluke or is there something more going on here. So we have what we have here is the issue of, is this something that is persistent in, let's say, an evolutionary setting, which is to say that we let the population of players evolve over multiple tournaments. So initially we said we are playing only one round of the game, what happens for multiple rounds, and now we are saying multiple rounds comprise of one tournament, what happens across multiple tournaments. So here what we are going to do is play one tournament, tally up the scores, and we are going to follow the Darwinian idea of the survival of the fittest. So the people with the weakest scores, the smallest scores, get eliminated from the game, and the people who have the highest scores basically get duplicated. Okay, so this is the idea of the survival of the fittest, and we are going to do this until we reach some sort of a stability in the population. And the question is, if you do this multiple times, which are the players who are going to survive? And this is actually quite interesting, and you know, let's look at what happens. So we have gotten rid of the detectives and the grudges because they are a little hard to keep track of. So it's a pretty simple setting. We have copycats, the always cheaters, and the always cooperators. So the nice guys, the mean guys, and the smart guys. Okay, so that's the three players we have, and we are taking the nice folks and we are giving them a bit of a leg up because they seem nice and super naive. So we are giving them an initial boost. So there are 15 cooperators and 5 each of copycats and always cheaters. Okay, and we are going to do this thing where we take the top 5 and delete them, the bottom 5, the bottom 5 and delete them, and the top 5 and replicate them. And if we keep doing this, the question is what happens in due course. So I think the question is badly phrased here. What I mean is, yeah, who do you think will survive if we do, so let me just check if I have, yeah, so the question here is who will survive at the end. So I don't know why I said who will win the first tournament. What I mean is who will survive in the long term. So if it is one tournament, we saw that copycats win, but now we are really talking long term over a period of time. So the only thing that the always cooperates have going for them is this initial boost. Other than that, they were pretty weak in the single tournament case. Always cheaters, we have seen that they have a pretty ruthless strategy, and the copycats had the thing that they actually won the single round case. So okay, again, always cheat is leading by a substantial margin, and this is not going to change. So, oops, sorry, that's not what I meant to do. So I'm going to guess that it's the cheaters who win in the long run, which would be a pretty sad sort of a theorem to prove, but okay, let's see. Okay, so let's play one tournament, look at what happens. And what happens here is not surprising. The cheaters dominate and the nice guys are at the bottommost rungs of the ladder. They do get 330 coins. This is because when they're playing amongst themselves, they benefit. Also when they play with the copycats, they benefit. But all of that is pretty much nullified when they play with the cheaters who take a lot of it away. Okay, so when you eliminate the bottom 5, the nice guys go away, and you reproduce the top 5, you get many more cheaters now. Let's do this again. It's going to be the same story, and it's going to be the same story again. And now you have a really dominant population of cheaters who are now facing the copycats, essentially. The nice guys are all gone. What do you think will happen now? So we haven't played the game yet. So how many? So let's see. There are 7 copycats. I think we had 25 players to begin with, so there must be 18 cheaters. So 18 versus 7. But roughly, you can just think of it as a majority cheaters and a minority. So what do you think will happen now? Will the cheaters dominate or will the copycats dominate? Cheaters. So let's maybe think about it a little bit more. When the cheaters play against the copycats, do they gain? They gain, how much do they gain when they play 10 rounds? When a cheater plays with one copycat for 10 rounds, they get 3 coins from the first round and 0 from the rest, right? When cheaters play amongst themselves, their balance sheet is 0-0, right? So they are going to gain 3 coins from each copycat, but that's pretty much it, right? Right, but when the copycats play off with each other, they gain in every round, right? And when they play with the cheaters, they do lose, but not much. I mean, certainly it's not a massacre like it was with the nice guys, right? So let's play this tournament and see what happens. And it turns out that what happens is fairly dramatic, meaning that the gap is quite high. So there were 7 copycats and each of the cheaters got 3 coins from each of them, so that's 21 coins. But the copycats are much more because they actually gain from each other. The problem with the cheaters is that they're so mean that even amongst themselves they don't stand to gain anything, right? So they are basically getting a taste of their own medicine here. That's what's happening. So now we have the cheaters slowly diminishing and the copycats reproducing. And it's not surprising that this story will pretty much repeat itself. With more copycats, it's even harder for the cheaters to, basically get anything, meaning that the gap is going to increase. So in absolute terms, they get more coins because they had more copycats to play with. But because there are more copycats, they also gain much more when they leverage, the intra connections between themselves. So this pattern continues for a while, and I think at this point nobody will be surprised to see that the cheaters are all eliminated. So the cheaters were basically too smart for their own good, and as long as there were nice people hanging around who could be exploited, the cheaters got away with it. But when they got stuck with the smart guys, that's when they themselves got eliminated. Okay. So it turns out that the copycats emerge victorious even in this repeated evolutionary sort of setting, which is kind of cool. So this works even if you bring back the grudges and the detectives. This is something that you can again check. So seems to be a small issue with the graphics, but okay, I mean, you can convince yourself that this works out. So okay, so here's the message here that copycat's philosophy is not just a moral truth, but maybe there is some essence of it being a mathematical truth. And now the issue at this point is that we've probably learned a lot about what breeds trust. I mean, in some sense, the moral of the story so far is that trust breeds trust. If you reciprocate, then that seems to be working out pretty well for the copycats. But we started off also by trying to address the question of what breeds mistrust. There are two parts to the question. With the World War I story, you were trying to understand what breeds trust, and some of this addresses that. But what is the issue of distrust? And here there are several ways of addressing this. I don't know how much time we will have to look into this completely, but let me try and at least allude to a few aspects. So one is that we are looking at okay, so one is that we are looking at a game which has 10 rounds per match. Okay, if we increased or reduced the number of rounds, do you think this will change the outcome of this whole scenario? And do the number of rounds matter? So what we said was that when the copycats play with each other, right, they end up gaining enough of a benefit to beat the cheaters in the system, right? So do you think that they actually need, they actually need the time to be able to build up enough of a deposit to be able to beat the cheaters? Or do you think that, even if there was 1 round or 2 rounds, that would have been enough? So I may have this as a question that you can vote on. So who do you think wins the game if there was only 1 round per match? Is it still going to be copycat or the cheaters or the cooperators? Sorry? So if the setting is not clear, it's essentially this. So you can even imagine this composition where you have a lot of nice people, okay, but when they're all playing against each other, they only get 1 opportunity, right? So in this case, who do you think will dominate the long-term game? What's the composition? There are lots of nice people and 1 cheater and 1, they're probably like 23 copycat. So 1 copycat and 1 cheater. So in every match, you only get to play 1 round. Previously, we were playing 10 rounds, remember? That's why we had like plus 30, minus 10 and all that. Now it will be plus 3, minus 1. So the sense seems to be that this will swing in favor of the cheaters, and indeed, let's see what happens here. You do notice that the cheaters start dominating. So let's see what's happening in one step. With just 1 round, I mean, the phenomenon that we observed before was partly happening because across multiple rounds, you had enough time to actually play off of each other's nicety and build up your coins, and the cheaters started losing out beyond that first round. But if you play only 1 round, notice that the 1 round is where the cheater has the largest leverage, and that's why it's not surprising that with just 1 round the cheater actually has a great advantage, and the others don't get enough time to kind of build up build up their deposits. And you could step through this and see that this phenomenon sort of just proliferates. And in fact, not just 1 round, there is sort of a balancing act here. If I remember correctly, even up to 5 rounds per match is not enough time for even the copycats to collectively dominate. So you will see that the cheaters start dominating if you don't give these games enough time to evolve. Yeah. So this is, I think it swings when you do 6 rounds. So again, this is something that I would encourage you to basically play with and build your intuition for over time. I think this is the turning point. So yeah, with 6 rounds is when you get just about enough time. That is with this particular choice of numbers in this particular payoff matrix. Yeah. So here the point is that the fewer opportunities for repeat interactions, the more distrust spreads, because this is where the cheaters are dominating when you are playing 5 or fewer rounds. This is a point where we also want to reconsider the payoff matrix, and again, I don't want to get too formal here, but notice that these numbers also, the way they are set up, drive the behavior of everything that we have discussed so far. So you could ask yourself what happens if these numbers change and if the payoffs were set up differently, right? So if you change, for example, the both cooperating reward to +1, which is still better than both cheating, right? If you both cheat, you get nothing. If you both cooperate, you're still getting at least 1 coin. But nonetheless, the small change in the payoff matrix actually influences the outcome of the game. So as you can see, the cheaters start dominating again. So here again, this is something that is fairly interactive. So when you have time, you should play around with the payoffs and see how it changes the fate of the game or how it influences what's going on. And here we continue to have 10 rounds per match, but it's still not enough to build up enough of a gap. Okay. So so again, this is I'm not going to, at least we are now not going to define these things very formally, but the intuition is that if your payoff matrix is such that you have set up what is called a zero-sum game, which means essentially that my win is your loss or that your win is my loss, meaning that there is a fixed amount of resources and if you get them, I don't get them. So if that's the kind of setup that you have designed, then that leads to behavior where people are basically going to claw in to get ahead of the game, because they really believe that the only way to get ahead is by putting other people behind. On the other hand, if you set up a payoff matrix which proliferates win-win situations, which is to say that, I mean, ideally you want to create a situation where people feel like the only way for them to win is also by helping somebody else do well. That's when you create a situation where people are compelled to cooperate. So as somebody who is, so typically in an application setting, you are playing God in the sense that you are trying to set up or you're trying to design a payoff matrix, you're trying to design the reward mechanisms in such a way that people exhibit certain desirable behaviors, right? So, so there are two broad themes in which a bunch of analysis happens. One is that you are given a scenario and you are requested to analyze it and you are trying to figure out what happens. That's what you've been doing so far. But you could also say that you wipe the slate clean and you set up certain goals for yourself, and you say that you want to set things up in such a way that it encourages certain behaviors from the players and from the participants. It's from that perspective that these terms are being introduced here, to say that if you had the freedom to set up a payoff matrix as you like, then you should try to create scenarios that are win-win rather than zero sum. Okay. But as I said, all of these things have, all of these things can be very nicely formalized. It's just probably not the best time of the day to do that right now, but I think in due course, over in various other contexts, these are concepts that we will revisit. Another interesting aspect to this whole thing is the issue of errors in communication. So this is also something that is a culprit for breeding mistrust. So let's just go through this quickly. So suppose we have two copycats playing against each other, which is kind of nice guys playing off with nice guys in the nicest possible setting. So they're both going to cooperate, which goes according to script, and you get this nice situation. But let's say in the next round there is a cheat move which has been made by mistake. Okay, so this could be a phone line that gets noisy and something nice that you're trying to say sounds like sounds like an expletive on the other side of the line, and then that leads to misunderstandings. Your friends hung up on you because they thought that this conversation was not being so nice. So that's what's happened here, and now that the other player, the player on my right, has interpreted this as a cheat move, how is the next round going to go? It's going to be the left player cooperating, reciprocating the prior cooperate move, but the right player is going to cheat. And what's the next round going to be? It's going to be like a cheat cooperate. So they're never going to go back to this nice situation of both players cooperating. It's going to alternate between cheating, cooperating. So it's sort of this endless cycle of vengeance is I think how he puts it. So mistakes can be a problem. Unintentional errors in communication also lead to unintended consequences, and you want to see if you can introduce strategies to sort of nip these in the bud, so to speak. So at this point we have new players, which are the goal with introducing these strategies is to see if we can be robust to errors in some sense. So copy kitten is a kinder version of copycat, which is essentially someone who cheats back only after she has been cheated twice rather than immediately reciprocating, right? So that builds in a little bit of cushioning. It lets you make one mistake and still get away with it, but you cannot keep you cannot keep making mistakes again and again, right? Simpleton is another variant where you start off by cooperating, and so it just repeats the last move even if the move was a move that was made in error. And so if you cooperate, I do the same thing as the last move even if it's a mistake. If you cheat back, I do the opposite thing as the last move even if it's a mistake. This can be a little confusing to parse in the first shot, and right now I'm not even going to ask you to worry about it, but in the rest of the simulation there are more examples that you can walk through that build up some intuition around the behavior of copy kitten and simpleton. So I mean, personally for me Simpleton wasn't that simple to parse out, but at the same time it's probably just, I mean the name is probably because that it's a blind strategy. It's just it's not putting serious thought into what it's doing, but yeah. The easiest to describe is perhaps random, which is just what it says. It doesn't account for the behavior of the other player at all, just plays cheat or cooperate randomly by tossing a coin, which presumably some of you were doing when you were playing, when you were at a loss on what to do or it wasn't clear, then you could just play randomly. So So again, you could get these folks to play in a tournament here, and okay, I'm probably going to, okay, so do you want to place a bet here? I don't think I have a voting question built in for this, but do you want to place a bet between always cooperate, copycat, copykitten, simpleton and random, where we are still doing 10 rounds in a match and there is a 5% probability of making a mistake. So who do you think will come out on the top? So the strategies are hopefully clear. So we already know copycat and cooperators from before. Random is random. Copykitten cheats back only when cheated twice in a row. And simpleton does some complicated thing which I'm flashing here briefly if you want to think about it. So who do you think is going to win? So it's the same setting, 10. So we are going to be doing these tournaments with the eliminations. How do you think this will go? Copykitten was just like copycat, but cheats back only when cheated twice in a row, rather than. So if you cheat, it will not immediately cheat you back, but if you cheat and cheat, then it starts cheating. So this is a little, well, okay, at least, I mean, speaking for myself, this is a little harder to think about because of the randomness that is involved. So there's a 5% chance that there is a mistake. And there is also a player whose strategy is random. So we have only been playing with deterministic players so far. So it's not, it's even, I mean, it's harder to even make an educated guess perhaps. But a guess is a guess, so do you want me to place a bet on something? Is there a favorite? So at this point, I'll take anybody's response. It doesn't. Copycat again? Okay. Alright, so let's just go with copycat again. You see how this. So the nice people always get eliminated quickly. Okay, so it turns out that at the end the simpletons survive, and I'll let you build up the intuition for this offline. But yeah, I mean, in brief, it turns out that between the simpletons and the always cooperators, the simpleton has certain advantages because when the cooperators don't retaliate, it continues to be like an always cheat strategy. But okay, so here what is different from the previous setting? Sorry, I think. Okay, I think I did. Sorry, I'll have to quickly run through this again to get you back to. I just wanted to show you the distinction from the previous setting, which is that this is the introduction to mistakes. Okay, so the difference from the previous setting is the composition, the initial composition. So notice that here you had a lot of nice players, right? About half the population was nice, and then you had a small number each of the other varieties of players, right? And notice that here you did not have any cheaters at all, right? So it was the really nice players and the copycats, the copykittens, the simpletons, and the random players, right? And now, as we know, simpleton was the right answer in this case. or it just turned out to be the right answer. I'm not implying that we have fully understood it. But here, in the initial composition, instead of having a large number of nice players, you have a large number of cheaters. Remember, one of the reasons that the simpletons came out on the top was because they had all these nice players to exploit, right? And they were able to build up their bank based on all of that population. And now this is a more hostile environment. Who do you want to place your bets on? So here you do have the cheaters sort of back in the mix. The rest of it is the same. And I think it's still the same setting where there is a 5% chance of somebody deviating from their actual strategy and playing something different. So again, if you just had to guess. Sorry, you were saying? No, nothing? Okay. Cheaters? Okay, so the hostility is coming from the cheaters, so let's see if that's what ends up happening. Okay, so I don't know if you followed the whole story there, but what happened was that the always cheaters did eliminate the simpletons, get them out of the way, but then the always cheaters ended up getting stuck with the copycats, whom they are not very good with. So the copycats ended up eliminating the cheaters, and now the copycats end up with the copykittens, and in a contest between copycats and copykittens, you want to think about who fares better. It turns out that the copykittens, I think, end up overtaking the copycats eventually. I think it takes some time, but they end up overtaking copycats eventually. So it's a little counterintuitive again, because the copykittens seem like in some sense a weaker version of copycats because they are more tolerant. But at the same time, we even designed them that way to be more robust to mistakes, and that is a behavior that seems to be emerging here, right? So again, so again, this will probably take some, I mean, all of this is really at the level of examples and intuition now. We've not really formally proved anything, and I want to be clear about that. But having said that, the one aspect that we have not tweaked here is the extent of randomness in the mistakes, right? So there is, all of this was in the context of a 5% chance of miscommunication. And it's interesting to see what happens when you vary this, right? And it turns out that slightly different players end up coming out on top depending on the amount of errors there are in the environment, right? So you can vary this from the original setting, which is the deterministic setting and there are no mistakes, all the way to 50%. And there's no point going beyond 50% because it's symmetric. So yeah, I mean a 75% chance of, yeah, I mean at the, okay, sorry, it's not symmetric, but that beyond 50% chance of error is just as good as flipping a coin, right? So it's, yeah, so that's why it's not reasonable to look at it beyond that. So, so this is something that I think is best played around with individually. So I would say stop at the screen and check out what happens at different levels of probabilities of error. So this is, I mean, this is going to be the outcome. I don't want to spoil it for you. Just you know, just try and see what happens at different levels of error. But I think the key takeaway here is the second paragraph, which basically says that a little bit of miscommunication can actually be managed by players like the copykitten, as we saw. But if you end up having a whole lot of it, so what is not surprising is that at 0% copycat is the old winner, because that's a setting we have discussed in detail. But what happens when you have a lot of mistrust is that, as we are seeing in this paused snapshot here, the cheaters do start to dominate. So if you have a lot of miscommunication and a lot of errors in your system, that also leads to proliferation of mistrust, and players like cheaters will start to dominate. So in this simulation, there is also this very convenient sandbox mode where you can tweak the number of players of each type. and set up your own payoff matrix and really see how these populations evolve. So, so when you have some time, I would really encourage you to play around with this. It's fun and it gives you a sense of what's going on. But essentially the three things are that we saw that the number of rounds plays an important role. So 10 rounds was 5 to 6 is where the transition happened. At 6 rounds is when fairness started emerging, fewer rounds than that and the cheaters were still winning. The second thing is the setup of the payoff matrix. We spoke a bit about zero-sum games versus win-win situations. And the last thing that we alluded to was this idea of miscommunication and possible errors in how you report your moves and how that can be handled by modifying the strategies of the players appropriately, but also observing that if there is too much miscommunication, that is again something that becomes difficult to handle, right? So, so as I said here, the simulation does end with a little bit of philosophy, which again there is this and the two books that I mentioned in the beginning make for really interesting reading if you're interested in the slightly practical and philosophical aspects of game theory. And I think we're going to pretty much stop here, but I hope that some of these ideas will keep surfacing in different ways throughout the rest of the lectures. I just wanted to take a break and give you a taste of strategy and playing and things like this. So the plan for the tutorial today is that I think some of you have had a chance to already go through the second tutorial sheet. So both the tutors are around. I will let you work it out. I'll let you folks work it out with them as to when you want to meet and how you want to do it. Tomorrow we will continue talking about voting in greater depth, and we will allude to issues of both, a little bit of the axiomatic impossibility theorems to begin with. We will let that motivate the computational problems, and for the rest of the day that is what we will focus on. Alright, so that's a wrap. Thanks very much.